This is part 2 of the homework video guide for trig derivatives, and for this very first question on the homework video guide, I have a implicit derivative problem. And for this particular problem, we still need to use the derivative of sine x and cos x. And if we start this problem, it looks like we have a product on the left-hand side here. So I need to start by taking the derivative of the expression on the left-hand side. And the derivative of y is going to be y prime. And then I multiply that by the second term, which is sine 2x. And then I add that to the derivative, I add that to, well, I have the first term now, and then I multiply by the derivative of the second term here, and the derivative of sine 2x will be cos of 2x. And then the chain rule states that I need to multiply by 2x, which is just 2. Sorry, the derivative of 2x, which is 2. Okay, so that's the derivative on the left-hand side, and then on the right-hand side, it looks like I have another product. So the product rule states that I times by the derivative of the first term. Now the derivative of the first term is just 1, right? So the derivative of x is 1, so I can just take that and multiply that by cos of 2y. And then the product rule states that I need to add. And then let's take the first term, which is now x. And then I multiply by the derivative of cos 2y. And the derivative of cos 2y, well, the derivative of cos is negative sine, so let's put this in a bracket here. So negative sine 2y. And then the chain rule states that I need to take the derivative of 2y, which is just 2y prime. And I close the bracket there. Okay, so there's my derivative expression there. And what I need to do now is I need to get the y primes all on one side here. So if I take a look at this term right here, and if I take a look at this long term over here, I'm simply going to just interchange those two terms, all right? So I'm going to bring one term to the right-hand side, and the other term I'm going to bring to the left-hand side. So if I write that out correctly, I have y prime, and then a bracket sine of 2x. Okay, and then if I take a look at this term over here, I have an x multiplying with a negative coefficient here and a 2y prime. And if I bring that all to the left-hand side, it becomes positive. It becomes positive 2x y prime, and then I multiply that by sine of 2y. Okay, and then I have an equal sign, and then I have cos of 2y. And then if I multiply this 2 and this y, I get 2y, and that becomes negative if I bring that to the right-hand side. So negative 2y times bracket cos of 2x. Okay, that's looking pretty good now. And now I have a y prime here, and I can factor out the y prime. So y prime, and then I need a big square brackets here, and then I have sine of 2x plus 2x bracket sine of 2y, and that equals to cos of 2y minus 2y bracket cos of 2x. Okay, so unfortunately I still have to write out all those algebra steps, and then all we're doing is factoring out the y prime, and then I guess what we're going to do now is we're going to divide the left-hand side by this yellow term right here, and it turns out that we can kind of jump to our final answer here. I have y prime, and then on the right-hand side, once again, I need to copy out all of this. And then I'm going to divide that by the expression highlighted here in the yellow term, right? So we're just dividing both sides by that, and I should get sine of 2x plus 2x bracket sine of 2y. Okay, so that right there should definitely conclude that particular problem there, and you don't need to simplify anything. So I really feel like that first step is the derivative step, and then everything else is just pure algebra. Okay, let's move on to some tangent line questions now. So we can't finish off this homework section without a few questions on the equation of the tangent line. So yes, when we're finding the tangent line, we're giving you some trig functions, and I've also just kind of put in some references over here on the left-hand side here. These are some basically some formulas and some reference numbers that you can definitely find on your formula sheet, and your job is to be able to locate that on your formula sheet. Okay, so let's go ahead and figure out the equation of the tangent line here. So I know the x value is pi over 4. And what we're going to do now is let's go ahead and find the y value, right? So the y value we can find by evaluating f of pi over 4. Actually, before I even evaluate f of pi over 4, if I look at my function here, I have this. And using the very first trig identity here, we know that tan x is sine x over cos x, right? So instead of writing sine cubed over sine cubed x over cos cubed x, I can write this as tan cubed x. And that's using this identity right there. And this is the same thing as bracket tan x all to the power of 3. And now I need to evaluate f of pi over 4. So we're trying to find the y value right away. And if we do that, we can just plug in, anytime we see an x variable here, we're just replacing that x variable with pi over 4. So pi over 4. And then I close the bracket, and this is being raised to the power of 3. Okay, if I used this reference point right here, we know tan of pi over 4 is 1. So this is the same thing as 1 to the power of 3, and 1 to the power of 3 is simply 1. Okay, so what does that really mean? What that really means is that we found our point, and our point where the tangent line intersects the original graph is at the point pi over 4, comma 1. Okay, so that's exactly what we just found right there. And if I update my tangent line, it's just basically y minus 1 equals to m bracket x minus pi over 4. Okay. All right, so after that, we can now jump into finding the derivative value. So I need to find this m value here. So we need to find the derivative. So once again, we concluded that the original function was really this, right? Bracket tan x all to the power of 3. And if I take the derivative now, y prime, using the power rule, this 3 will come into the front. So 3 and then bracket tan x. And then the power rule states that I need to decrease the power by 1. But the chain rule states that I need to multiply by the derivative of the inside here. And what's the derivative of tan x? Well, it's this thing right here. So it's going to be secant squared x. Actually, I'll write that as secant squared x. And I guess one more thing now, we need to find the derivative at, okay, so that's the derivative expression there, and we need to find the derivative at pi over 4, right? So just if I have to just change my notation here, I'll write this as f prime of pi over 4. And what that means is anytime we see the x values, we need to replace that with pi over 4, right? So this equals to 3 bracket tan, I'll use a red marker now, pi over 4. All to the power 2. And regarding the secant squared, I'll rewrite this now using this notation here with the power 2 on the outside. So if I rewrite this correctly, it's like I have secant all to the power of 2. So this 2 is really that 2 right there. And then I need the pi over 4. Okay. Okay, so let's start with the tan expression here, because we know that tan of pi over 4, as indicated before, is just 1, right? So this is all going to be 1 to the power of 2. And then I multiply this by secant of pi over 4, right? Okay, well, what we're going to do over here is, if I just go over here, I know that cos of pi over 4 is 1 over root 2. And that means secant of pi over 4, that's just the reciprocal of, pi over 4. This is just the reciprocal of cos pi over 4. So if I have 1 over root 2, the reciprocal is just that flip. So a secant pi over 4 is really root 2 over 1, which is just root 2. Okay, so basically what I can do over here is I can write root 2, because secant pi over 4 is root 2, and then I just square that. And that right there kind of gives me all the numbers I need. So this is going to be 3 times, and then root 2 squared is going to be 2, and 3 times 2 is going to be 6. Okay, so if I go back to my final answer here, this is my tangent line over here, this red box here. If I just erase the m value now, the m value now was 6, right? And that right there is the equation of the tangent line. Okay, before we finish off this problem here, let's just show another quick little visual graph of what's going on in this particular problem here. Now, this graph right here kind of shows you the visual solution of the problem here, and what I'll write first is the original function, which is in red, is really the sine cubed x over cos cubed x, and we kind of stated that that's the same thing as tan cubed x. So that's the equation of the red line there. And this intersection point is where the tangent line intersects the original graph, and I guess that intersection point was the very first thing we found in the problem, which was pi over 4 comma 1, I believe. And then what we also have here is the linear line in blue, and that's the equation of the tangent line, which is y minus 1 equals to 6 bracket x minus pi over 4. Right, so that's a visual diagram of what this problem looks like. Is the equation of the tangent line, and I guess we intersect at this xy value, which is pi over 4 comma 1. Okay, great. Let's move on to the second question now. We have another tangent line question here, and I know that the x value is pi, so what we're going to do here is we're going to evaluate f of pi over f of pi. And what that really means is that anytime we see an x on the original function there, those x values will get replaced with pi, right? So this is going to be pi squared times cos of pi. And if we evaluate this, pi squared is just going to be pi squared. And then what's cos of pi? Well, cos of pi you can find on your reference sheet here, and I have it right here as well. So cos of pi is going to be equal to negative 1. So I times this by a negative 1, and I get negative pi squared. Okay, so what does that really mean? Let's just erase all this, and I know that the intersection point where the tangent line meets the original graph is going to be at the point pi comma negative pi squared. Okay, and then if we had to update the tangent line, I guess it would be y plus pi squared equals to m bracket x minus pi. And once again, now we need to find our derivative value, which is the highlighted by the letter m there. Okay, in order to do that, let's go ahead and find the derivative here. Before I do that, let me just rewrite the original problem here. So the original problem is y equals to x squared times cos of x. And we need to find y prime, right? Alright, so using the product rule again, the derivative of x squared is going to be 2x. And then I multiply that by cos x. Whoops, got my cos wrong there. So cos of x, and then the product rule states that I need to add, and I add that to the first term, which is x squared. And then what's the derivative of cos x? Well, the derivative of cos x on the left hand side here is going to be negative sine x, so bracket negative sine x, and that's looking pretty good now. And now I need to evaluate the derivative at pi, right? So now I need to write out f prime of pi. So what that really means now is all these x values are going to be replaced with pi, right? So this will be 2 times pi times cos of pi, and then I have a plus, I guess, pi squared times negative sine pi. Okay, and using this factor right here, we know that sine of pi is 0, so all of this, since sine of pi is 0, all of this will just go to 0. Okay, so now we have f prime of pi equals to bracket 2 pi, and we know that cos of pi is equal to negative 1, so my derivative value will be negative 2 pi. Okay, so that's looking pretty good there, and if I have to write out my final tangent line here, I guess I have y plus pi squared equals to negative 2 pi bracket x minus pi. Okay. All right. So basically, what I've done now is basically, if I go back to my my problem here, I'm just once again, if I go back to this red box here, I'm just replacing the m value now with negative 2 pi. Okay. Before I finish off this problem here, let's just show another visual graph of what's going on. So I kind of went to Desmos and sketched this out already here. And if I take a look at the blue graph is the original problem. So y equals to x squared times cos of x. So that's the equation of the graph highlighted in blue. And this intersection point right here, This is actually the very first thing that we're finding in these tangent line problems. So if I go back to my work here, it's this thing right here, right? The pi comma negative pi over 2. So this point right here is pi comma negative pi squared, sorry. I think I said pi over 2 in my previous step there, but it's actually just pi comma negative pi squared. That's the intersection point. And the red line has the equation of the tangent line, which is y plus pi squared equals to negative 2 bracket x minus pi. Alright, so that's a nice little visual of what's going on in this particular problem, and that red line is just that linear line that we just found. Okay, let's try one more tangent line question here. Okay, so this is the next problem that we have, and now we have y equals to, the original problem is y equals to sine x times cos x, and we want to find the equation of tangent line at x equals to pi over 6. Okay, so I recommend that we find the y value first, so we need to find f of pi over 6. Okay, so basically what that means is that anytime we see an x in our original problem, all those x's get replaced with pi over 6. So this will be sine of pi over 6 times cos of, now if I have cos of 2 times pi over 6, the 2 and the 6, that really becomes pi over 3, right? So 6 divided by 2 is 3, so I can erase this part now, and I can write just pi over 3 here. Okay, and if you're not quite familiar with how to find all these trig ratios yet, I recommend that you can go to your formula sheet, and your formula sheet should have all of these ratios on there. And I've gone ahead and I've kind of written out the ratios in advance right here. So sine pi over 6 is right there, and cos of pi over 3 is right there, right? So if we continue here, sine of pi over 6 is going to be 1/2, and cos of pi over 3 is going to be 1/2 as well. So 1/2 times 1/2 is going to be 1/4. Okay, so what that really means is that the intersection point of the tangent line and the original graph happens at pi over 6 and 1/4. Okay, I'm going to erase all that. And once again, if I were to update my tangent line here, it would be y minus 1/4 equals to m bracket x minus pi over 6. Okay, and our goal now is I need to find the derivative value there. Okay, so let me start off by writing out the original problem again now to find the derivative value. So I know the original problem is this, and I need to find the derivative, and if I'm finding the derivative, I'll write that as just y prime. And now I need to use the product rule, right? So the derivative of sine x, if I look at my little cheat sheet here, the derivative of sine x is cos x, so bracket cos x times cos of 2x. And then the product rule states I need to add, and I need to add the first term, and the first term is just sine x. And then I need to multiply by the derivative of the second term. Now I know the derivative of cos x is going to be negative sine x. So let's put a bracket negative sine x. So negative sine of 2x here. And then the chain rule states that I need to find the derivative of 2x, which is just 2. Okay. Alright, so then from there, I need to evaluate this at the derivative point, which is f prime of pi over 6, right? Alright, so if we're doing this particular problem again, it just means that all the x values get replaced with pi over 6. So if we do that correctly here, I have bracket cos of pi over 6. Close that bracket. And then I have cos of 2x. So if I take 2 times pi over 6, that's going to be pi over 3, right? So this is cos of pi over 3. And then I add that to sine of pi over 6. And then I have a negative, I guess this will be a pi over 3 again. And then times this by a 2. Okay, so that's looking pretty good here. And then fortunately for now, we actually have to just do all the brute work here and actually replace everything with the ratios here. So if I continue on here, let's just find out what is cos of pi over 6. well, cos of pi over 6 over here using my reference chart right there is pi over 3, right? Sorry, root 3 over 2. And then ask yourself, what's cos of pi over 3? Well, cos of pi over 3 is over here, which is just 1/2. Plus, and then I have sine of pi over 6, which is over here. Sine of pi over 6 is 1/2. And I have negative sine of pi over 3, so I got to use this part right here. So that's going to be negative root 3 over 2, and then I multiply the whole thing by 2 here. Okay, so this is the last expression here. Now we got to multiply this out, so I guess this is going to be root 3 over 2 times 2, and 2 times 2 is going to be 4. And then I can see that this 2 and that 2 will cancel off, so I have a negative root 3 over 2. Okay, so this is looking pretty good right now, so I guess we need to get a common denominator here. So instead of having a 2 there, I can replace that by a 4 by timesing by 2, so I need a 2 there as well. And then there's a 1 here, so if I take the 1 and subtract the 2, I get negative root 3 over 4. Okay, so that's it. So negative root 3 over 4. If I go back to my tangent line at the start of the problem here, I guess I'm just going to highlight this box here. And let me just erase that. And what we just found was negative root 3 over 4. Okay, so that's looking pretty good for the tangent line here. And just before I conclude this homework video guide, here's another visual of the graph here. And we have a trig function here in red. So the red function is the original problem. So if I rewrite this, this is y equals to sine of x times cos of 2x. That's the equation of the graph in red. And this intersection point right here, as mentioned, that is the intersection point that we found at the start of the problem, which was pi over 6, comma 1 over 4. And that purple line is the equation of the tangent line, and the purple line is the line that we just found, which was y minus 1 over 4 equals to negative root 3 over 4 bracket x minus pi over 6. Okay, so that concludes this homework video guide, and that last graph shows you a visual of the answer that we just found and what it looks like when it's tangent to a trig function.